intramolecular cross reduction that leads to the formation of addition products. Cross reduction products. This is the general kind of reaction. Whenever we are taking an example, that reaction you get here. This is 3-hydroxy. 1, 2, 3, 4, 5, 6. 3-hydroxy 1,5 hexadenine 1,5 hexadenine, which is on irradiation in presence of mercury that leads to the formation of a cross reduction product. A cross reduction product will be generated. This is the cross reduction product. There is no change in the position of OH. Cross reduction product. How this reaction takes place? The mechanism. Whenever you are taking that 3-hydroxy 1,5 hexadenine, which is on irradiation, right, in presence of mercury, that leads to the formation of a transition state. The transition state is the this is 5 to 5 star triplet energy state. Triplet energy state, also called as triplet biradical. Triplet biradical. This triplet biradical first is undergoing the cross reduction. That means this electron is donated to this carbon center, or this electron is binds with the electron present at this carbon end. Then it leads to the formation of an intermediate, that is here the radical. One electron is here, another electron is here. Now this step is called cross addition. The first cross addition. Later, these two electrons are combined together. That leads to the formation of the product. Second cross addition. In the next bond. In the next bond. This electron, this electron. is the cross-radiation product. Cross-radiation product. The mainly in the both the cases, this is a triplet biradical. This is also biradical transition state. Biradical transition state. Okay, this is the general mechanism involved in the intramolecular cross-radiation reaction. Intramolecular cross-radiation reaction. Right. Other some reactions which are involved in the cross-radiation. You take the similar molecule, but in place of hydroxy, you take the double bond. You take the double bond. It leads to the two different kinds of reactions. Whenever we are irradiated with the right direct, there is no triplet sensitizer. Then it leads to the formation of singlet state, transition state. Then for other, it is undergoing a cycloaddition reaction. It involves, sorry, electrocyclization reaction. Electrocyclization, electrocyclization reaction that leads to the formation of a cyclic current will be generated. The cyclic current will be the cyclic product will be generated. The product. Okay. Suppose this is the same starting material is irradiated in presence of sensitizer. Any triplet sensitizer you are using, sensitizer that will be excited. First it is generated the singlet state, then the triplet, whatever the sensitizer used, that will be converting into triplet energy state. The triplet energy is bombarded with the molecule that is directly converting into triplet state. This triplet state is undergoing the cross-reduction reaction. It is undergoing intramolecular cross-reduction reaction. Then it leads to the formation of the polymer. That means this double bond is not participating in the intramolecular cross-reduction reaction. But whenever we are irradiating indirectly, it is just under the cyclization, retrocyclization. Okay, whenever we are irradiating with the substrate with the sensitizer, that leads to the formation of cross-reduction product. This is one method. Okay, we have several examples are there in your book. You can practice it, right? If you take Nar-Borna dye, suppose in previous case we are seeing that 1,4 dyes that is undergoing the diphenmethane rearrangement. But here in this case, this is non-Borna dye. Nar-Borna dye, which is on direct irradiation or in presence of sensitizer. Both the cases, it undergoes quadracyclic compound, the same compound, but there is unsaturated double bonds are vanished. That leads to the formation of a quadracyclic compound. known as quadracyclic cyclane. Quadracyclane. Right. Similarly, if you take the 1 comma 8 member ring, only it is having two double bonds at the position we consider 1, 2, 3, 4, 5, 6, 7, 8. 1 comma 5 cyclohexadiene, which is on the radiation in presence of mercury. This first it generates the transition state. The transition state is like that. That means it is the triplet transition state, that is 1, 2 biradical transition state. Suppose if it is undergoing cross addition, it is undergoing cross addition, then it leads to the formation of yes, one of the position of the double bond is found a bond like this, or vice versa. In the next step, these two electrons will combine to produce the another bond between those two carbons. A sigma bond is generated. Okay, this is one product. Now this product can be written as in non-planar structure, can also represent like this. Right. Actually, this is the non-planar structure. And this representation shows the planar structure. It shows the non-planar structure. Right. And if it is undergoing a 1 comma 2 hydrogen shift reaction, that is the real sigma-tropic rearrangement rearrangement. Sigma-tropic rearrangement reaction that leads to the formation of 1 comma 3 biradical intermediate, 1 comma 3 biradical, that is the hydrogen is shift from to here. One, two, three, four, 5, 6, 7, 8. This is 1 comma 3 biradical, which is further cyclization that leads to the formation of a 7-member ring, which is fused to 3-member ring. The double bond is. This is the one of the intramolecular cross-reduction reaction. Next, oxidations using singlet oxygen. Oxidation of the unsaturated bonds using singlet oxygen. oxidations using singlet oxygen. Now, first, before going to the reaction, first you need to understand about the oxygen. Generally, the oxygen at ground state, it is in triplet state. Oxygen at a ground state, it is in triplet state, right? The singlet oxygen can be generated by low energy triplet sensitizer. Suppose this ground state oxygen is irradiated with a triplet sensitizer that leads to the formation of a triplet oxygen to singlet oxygen. Triplet oxygen, like here this sensitizer, whatever the sensitizer used in this reaction, that may be a methylene blue, a dyes are, some of the dyes are used that are methylene blue or Bengal gram, sorry, rose Bengal. These are the dyes can be used as sensitizer. These dyes are absorbing the visible light. That visible light energy absorption that leads to the excitation of the dye. A triplet state is generated. The triplet energy will be transferred to the oxygen. Therefore, it causes the electron reversion or inversion that leads to the formation of singlet oxygen. Singlet oxygen. What are the methylene blue? The structure of methylene blue. It is a sulfur nitrogen containing heterocyclic compound. This is the methylene blue. Okay. Next, rose Bengal. Iodine is something O minus and also iodine. Now it is fused with the aromatically. The aromatized aromatic is also, and it is attached with a phenyl substrate. Substituted phenyl substrate U minus Cl, the rose penta. These are used as the sensitizers to convert the triplet oxygen to singlet oxygen. What is the mechanism involved in the conversion of singlet oxygen to triplet oxygen to singlet? A donor. The donor is here methylene blue or rose Bengal D. It is having the triplet energy state, and oxygen is already at a triplet state. Is already at a triplet state. Both will be bombarding to each other at the photochemical condition. Then exchange of this electron, that donor will be turns to singlet state, and also oxygen is also turns to first singlet state. Here the D is the donor or synthase. D is the donor or synthase. A wide variety of substrates can be oxidized with singlet oxygen. In that singlet oxygen involving the reactions. Singlet oxygen involved reactions are follows. First one, in reaction. First one is the in reaction. In that alkene substrates which are containing allylic hydrogens, alkenes which are containing allylic hydrogens are oxidized to hydroperoxide. The reaction occurs with the shift of double bond and may involve a concerted mechanism or a peroxide intermediate. Concerted mechanism, the peroxide intermediate can be isolated, it will be characterized. This is the allylic system. This is the methyl group. Like this. Now, whenever you are treating this reaction in presence of singlet oxygen, singlet in presence of sensitizer, then it leads to the formation of the corresponding peroxide. Corresponding peroxide. The product is peroxide. The product is hydroperoxide, alkyl hydroperoxide or argon hydroperoxide is generated. How this reaction takes place? Mechanism. Whenever the reaction is involved in the concentrate, that is intermediate can be isolated, that is involving concentrated mechanism. In the concentrated mechanism, take that same starting material. Now this is a singlet oxygen, right? These 5 electrons can be donated to this oxygen. 5 bonded electrons can be donated to this oxygen. This oxygen bonded electrons, oxygen electron can be donated to the hydrogen. This carbon hydrogen bond pair will be migrated to the peroxide organoperoxide. The mechanism can also show in a different way, that is involving peroxide mechanism or peroxidine mechanism. Peroxidine or peroxide mechanism. Peroxide mechanism. What is the having same substrate you can take it. Whenever it is treating with singlet oxygen, first it will be undergoing the oxidation of double bond. That oxidation of double bond lead to the formation of this peroxide-like structure. In that peroxide structure is having a negative charge, right? This intermediate can also called as peroxidine or peroxide. This intermediate can also known as peroxidine or peroxide. In this series having a positive charge and a lone pair of electrons here. Right? Now, after the formation of this peroxidine or peroxide intermediate, the intermediate can be isolated. The negative charge is donated here. Negative charge is donated here. Then the carbon hydrogen bond pair is donated to here. Simultaneously, this carbon oxygen bond pair will go to here to neutralize the positive charge. Then it leads to the product. What is the product? CH2 hydrogen is remaining here. The product. Write down peroxide. Okay. Another example, we take the cyclooctene. One of the double bond is there. Cyclooctene, which is subjected to oxidation with singlet oxygen in presence of sensitizer and irradiated with light. A small arrangement of the double bond, like in the previous example, the double bond is moving to this position. It leads to the peroxidation which takes place here. Okay, this is about the single reaction involving the singlet oxygen. Next reaction, dioxetane formation. Dioxetane formation. For example, an alkene without allylic hydrogens. The alkene system, a double bonded system or olefin system without allylic or benzyl, this is the allylic position. In this case, this is called allylic position. When this allylic position is absent, how the same reaction with a singlet oxygen, what's happening? Whenever you are conducting the reaction with the same singlet oxygen, what's happening on the molecule? Okay, this is the 1,2-dimethoxy alkene or ethylene. When it is irradiated with light in presence of singlet oxygen and sensitizer, then that leads to formation of dioxetine is generated. Dioxetine is generated. Dioxetine, there is no change in the positions of methyl groups. Similarly, you take another bicyclic system. YUV, which is treated with oxygen and on the radiation with a sensitizer. OCH3. This is the oxygen. Okay, the simple mechanism is very simple. This is the singlet oxygen. Then this double bond is donated here. Double bond is donated. That means a four-member ring with two oxygen is generated. Four-member ring with two oxygen is generated. That is called dioxygen. If you take Indian or Indian derivative, which is also subjected to the singlet oxygen addition in presence of sensitizer, then it leads to the formation of a simple adduct. Right. Later, it will be dissociated to like this. That leads to the formation of aldehyde group is here, and another aldehyde group is here. These are the products. Next, third kind of reaction with the singlet oxygen, dioxane formation. This is the dioxetane formation. Next, dioxane formation. Dioxane formation reaction. In the diene that can adapt in soil conformation undergoes 4+2 cycle addition with the singlet oxygen to give the dioxane. A six-membered ring will be generated. Six-membered ring will be generated. That is called dioxane. This is the 1,3-butadiene derivative, like phenyl, methyl, or phenyl, 1-phenyl, 1,3 pentadiene. 1, 2, 3, 4, 5. 1,3 pentadiene. Along with the substitution at first position, there is 1-phenyl. 1-phenyl, 1,3 pentadiene, which is on irradiation with light in presence of singlet oxygen and in presence of sensitizer. That leads to the formation of a six-membered ring. The derivative will be generated. That is called dioxane derivative. Right. We have several examples are there. For example, the same dioxane can be generated whenever you are taking the anthracene. The anthracene. Then direct irradiation. This is the some fused dioxane derivative. Some fused dioxane derivative. In this, when you understand this reaction, this is the anthracene. It is in the ground state, right? Which is an irradiation on direct. It leads to the formation of anthracene, first excited state, singlet first excited state. Now it is undergoing intersystem crossing. Then it leads to the formation of T1 along with a ground state. This T1 of the anthracene is generated. Then it is reacting with triplet state of singlet oxygen. Triplet state of oxygen. This is in the triplet state. Then it leads to the formation of anthracene at ground state. This is in the ground state. And the whatever the oxygen which is reacting energy, it is involved in energy transfer, that it produces the singlet state of oxygen. This singlet state is further reacting with the addition reaction that leads to the formation of this product. Okay, that is the mechanism involved in the formation of dioxide from the anthracene. Dioxide from the anthracene. Now, another example. Furan derivative. It is 2-methyl furan, which is on irradiation in presence of singlet oxygen in presence of sensitizer, and the solvent for this reaction is methanol. Then it leads to the formation of a product. Okay, such kind of product can also see in the case of cyclo-addition reactions. Cyclo-addition reaction can also see in such kinds of products, but where we are using olefins only, but here we are using the singlet oxygen. This transition state will be generated. Further, it is undergoing dissociation of this bond in presence of methanol. In presence of methanol, that leads to the formation of OCH3 substitution here. OOH3. Right. This is the one order. Next, suppose some terpene derivative. Now it is subjected to reaction with singlet oxygen in presence of sensitizer like benzophenone. Now, at presence of benzophenone sensitizer, that leads to the formation of this kind of product. This is ascaridole. Uh, is not alpha terpene, terpenine. Terpenine is okay. That's it. Look at here how this is simply a 5,4 plus 5,2 cycloaddition type reaction. Cycloaddition type reaction. What's happening? You take the 1, 3 butadiene, 1, 3 butadiene, which is subject to the suppose photochemical condition or thermal condition. It is thermal reaction. Suppose if it is thermal reaction, it follows the Diels-Alder mechanics. Similarly, the same reaction, if you are carrying out in presence of singlet oxygen to a chemical condition with presence of sensitizer or direct radiation, that leads the formation of oxime derivative, dioxide derivative. This is the product. Okay. This is about the formation of dioxins from the unsaturated substrates. Next, oxidation with superoxides. Oxidation of olefins or unsaturated systems. Oxidation of olefins or unsaturated with superoxides. Here the oxygen is the singlet oxygen. Oxygen is good electron acceptor and forms superoxides or a radical anion, which is a powerful oxidizing agent. A carbon-carbon double bond can be oxidatively cleaved by superoxide to yield the carbonyl compounds. For example, you take olefin, which is reacting with a singlet oxygen in presence of a sensitizer on direct radiation. The sensitizer is 9-10 diacyano anthracene. Then it leads to formation of a acetone is the product. Acetone is the product. For example, you take a Stilbene derivative, trans Stilbene. The same conditions, you are carrying out the reaction. Leads the formation of benzaldehyde is the product. 2 moles of benzaldehyde is generated. Now, what is the mechanism involved? That mechanism. First, dicyano anthracene, whatever the 9-10 dicyano anthracene is subjected to irradiation with light. First, it generates the singlet state. Singlet state. Now, the singlet state interacts with the olefin. The singlet state is interacting with the olefin. Therefore, it is involving electron transfer reaction. That means the electron is transferred from this anthracene to the this olefin to the anthracene. What's happening when the electron is transferred to this? One electron is transferred, then it leads to the formation of 9-10 dicyano anthracene. It is an intermediate. It is one radical and one electron. At the same time, the olefin becomes a radical cation. A radical cation. It's the radical anion. Radical anion. This is the radical cation. This radical anion further reacting with a singlet oxygen singlet oxygen. This electron is transferred from radical ion to this oxygen. It is 9 comma 10 dicyano anthracene is generated as is its neutral molecule. Then it leads to the formation of a radical anion. Radical anion. This radical anion can also represent like this. This is a negative charge. That. Now this radical is known as both will combine together or individually. It can be called as superoxide or you can also call as oxygen anion radical. Oxygen anion radical. Now this oxygen anion radical further interact with this carbon radical cation combined together that leads to the formation of like the compound is generated. First cyclic character will be generated. Later, this carbon-carbon bond is taken by this carbon oxygen. Simultaneously cleavage of oxygen-oxygen bond that leads to the formation of two molecules of carbonyl compounds. Two molecules of carbonyl compounds. Right? This is the mechanism, general mechanism involved in the oxidation of olefins or unsaturated systems using superoxides. Superoxide or oxygen anion radical. Oxygen anion radical. Okay, if you get to the one example, an aryl derivative, aryl derivative, which is treated with oxygen in presence of light, in presence of DCA, dicyanoanthracene. Right. This is the product. This is the product. Okay. How it is generated? Look at it. Similarly to the previous one, DCA, it is in the ground state. Whenever we are irradiated with light, it produces DCA, singlet state, is undergoing, this is the polyfill. Electron is transferred to this one. Electron transfer. Electron transfer. Then it leads to the formation of carbon. Carbon. Here the radical. Here this is the anion. Aryl. Aryl. Along with the DCA radical. Now it is reacting with oxygen at ground state that leads to the formation of superoxide anion radical and oxygen anion radical with a DCA singlet state. Now this DCA singlet state is maybe exist as when it is undergoing the simple addition reaction. In the positive charge, cation radical. Now both will combine together. It gives the formation of an adduct. The adduct is like this. Here this is the regular product, whatever I'm showing you here is distillate. Distillate. As previously we seen that the regular product. Okay. But here the both radical cation further reacting with whatever the radical cation generated reacting with another molecule of that olefin derivative that leads to the formation of this 1,4 by 1,4 radical cation generation. This 1,4 radical cation further undergoes the reaction with superacid, superoxide. Then it gets the formation of yeah. Okay. This is the product we generally see in the above reaction. Okay. This is about the oxidation with superacid, superoxide. Some other examples, if you take a three-member ring, this is 1 comma 1 diphenyl, 1 comma 2 vinyl cyclopropene. This is the same reaction conditions. Then it leads the formation of a five-member ring with two oxygen heteroatoms. Right. Similarly, aziridine can also participate in the reaction. A nitrogen three-member ring, aziridine, phenyl, phenyl, 1,2 diphenyl aziridine. This one is 1,2 diphenyl aziridine. Under the same reaction conditions, we will get the oxazoles. Dioxazole will be generated. This 1 comma 5 diphenyl. Sorry, I think the numbering starts from yes. Right. 1 comma, sorry, 3 comma 5 diphenyl, 3 comma 5 diphenyl, 1 comma 2 comma 4 dioxazole, diox, right? Similarly, if you take the oxirane, diaryl oxirane is the starting material, a three-membered ring, aryl and aryl hydrogen. It is also carried out the reaction the same condition. It leads to the formation of this kind of product. So this is not the bromide, aryl, aryl, right? 3 comma 5 diaryl 1 comma 2 comma 4 trioxolone, trioxylane. It is also known as an ozonide derivative. It is also called as ozonide. Okay, this is the these are the reactions which are involving in the unsaturated compounds with the singlet oxygen by the formation of by involving the ene reactions, dioxidate formation, dioxane formation, and oxidation with the superoxide. Okay, these are in the examination purpose. This question is important. This question is very much important. Write the reaction involved in the oxidation using the singlet oxygen. All the 5 reactions you need to write in your examination. This is asked as a long question in your examination. Okay. From this, we have completed 13 unit. Tomorrow we'll continue with the photochemistry of benzene and its derivatives. Photochemistry of benzene and its derivatives. We'll going to discuss about. Okay. Today I'm going to conclude the session. Tomorrow we'll meet the at the as per the timetable. If you have any doubts, you can ask me. Any doubts?
No, sir. No, sir.
Okay. Then I'm stopping the